Hello, this is quiz 2 on Amdahl's law. So to read the question, MIPS FP is a hardware coprocessor that increases floating point instruction execution by a factor of 2, which in my case, since my UCF-ID ends in a 0, is actually 4, compared to using a MIPS NICE general purpose CPU alone. For a data compression application on an enhanced system having a MIPS NICE chip and a MIPS FP chip, 5%, or in my case, yet again, 10% of the total execution time is performed exclusively by MIPS FP, and the remaining 90% in my case, exclusively by MIPS NICE. So the first part of the question asks, what speedup is achieved using MIPS FP compared to an unenhanced system using MIPS NICE alone? So we know that 10% of the execution time is going to be affected by the enhancement from MIPS FP, and we know that that 10% is going to be enhanced by a factor of 4. So you can actually use these givens to calculate the overall speedup in this equation in front of us. So that's going to be 1 over 1 minus fraction enhanced, which represents the unenhanced fraction of the execution time that is unaffected by MIPS FP, plus the enhanced fraction of the execution time divided by the speedup factor, which is going to give us 1 divided by 0.9 plus 0.1 divided by 4, which is going to give us 1.08108 fold. So the second question asks, what percentage of the unenhanced system's execution time would be executed by MIPS FP? So the percentage of the unenhanced system's execution time that would be executed by MIPS FP would be 2.5%, since the MIPS FP coprocessor is 4 times faster at floating point operations than MIPS NICE without enhancement, and MIPS FP comprises 10% of the total execution time in the enhanced system, which is just common sense. So the third question asks, or the third part of the question rather, asks, a MIPS NICE chip sells for $5, which again, in my case, is going to be $10. What is the maximum price of MIPS FP in order to provide a performance benefit per dollar in an enhanced system when compared to MIPS NICE alone? So we know the cost of the MIPS NICE processor is going to be $10, and we're also going to be letting MIPS NICE be the reference performance CPU, which means that it's going to have a relative performance of 1, because it's relative to itself. What that's going to mean is that the performance per dollar is going to be 0.1, since it's going to be 1 divided by 10. That being said, MIPS NICE enhanced with MIPS FP is going to give us a performance of 1.08108 fold relative to the unenhanced MIPS NICE CPU. So in order to be able to calculate the maximum price of a MIPS FP chip to provide a performance benefit per dollar over a regular MIPS NICE chip, the total enhanced system is going to have a better performance per dollar than that of the original system. That is going to be reflected in the following equation: 1.08108 fold over x is greater than 1 over 10, where x is going to be the maximum price of the entirety of the MIPS NICE system in order to be able to provide a performance benefit per dollar over an unenhanced MIPS NICE chip. And if you do the algebra, you're just going to multiply both sides by x. It's going to give you 1.08108, which is greater than x over 10, which gives x is less than $10.8108. This means that the MIPS FP chip would have to cost less than 0.8108, because we're talking about the chip by itself here, MIPS FP, not MIPS FP and MIPS NICE, in order to provide a performance benefit per dollar in an enhanced system that is higher than the unenhanced MIPS NICE system.